fraction is part of a whole. A decimal fraction is the part of a decimal number to the right hand side of the decimal point. In order to understand how binary fractions work, it's probably wise to review our knowledge of denary fractions first. After all, denary or base 10 is what we are used to when working with numbers. You probably remember from junior school that the denary column headings are called hundreds, tens and units. You may even know where these column headings come from. But what happens on the right hand side of the decimal point? We have the reciprocal of the column to the left of the units column. Reciprocal just means 1 over something. So we have 1 over 10 to the power of 1, which is 1 over 10, also known as tenths. Continuing this sequence, the next column on the right is a reciprocal of the column to the left of the tens column. So we have 1 over 10 to the power of 2, which is 1 over 100, also known as hundredths. Looking at this all written in the same format, we can see there's a pattern to the column headings. Note the connection between the base number, which is 10, and the exponent, sometimes called the power, shown in green. Can you see the pattern? The first column to the right of the decimal point is 1 over the base number raised to the power of the column number relative to the decimal point. So we have 1 over the base number, which is 10, raised to the power of the column number, which is 1, because we are one column to the right of the decimal point, which gives us 1 over 10 to the power of 1, which is 10. Therefore we have 1 over 10, also known as tenths. Applying the same method to the second column to the right of the decimal point, we get 1 over the base number, which is still 10, raised to the power of the column number, which is 2, gives 1 over 10 squared, which is 1 over 100, also known as 100. So we can express any mixed fraction, such as 1 3/4, as a decimal fraction, and in this case it becomes 1.75. We can apply this same method to other numbering systems such as binary, which is base 2, and it will identify the column headings after the point. In this case it would be called a binary point. Which means for the binary numbering system, the first column heading after the binary point will be 1 over the base number, which is 2, raised to the power of the column number, which is the first, which would give us a first column heading of 1 over 2 to the power of 1, which is 1 over 2, also known as a half. The second column heading is 1 over the base, which is 2, raised to the power of the column number, which is also 2, giving us 1 over 2 to the power of 2, which is 1 over 4, also known as a quarter. The third column heading is 1 over 2 to the power of 3, which is 1 over 8, also known as an eighth, and so on and so forth. So the 1 3/4 we converted to a decimal fraction earlier can now be converted to a binary fraction to give 1.11, which is 1 under the units column plus a 1 under the halves column plus a 1 under the quarters column, totaling 1 3/4. Because 1 plus a half plus a quarter gives 1 3/4. Simples. Now it's your turn. Try to convert 4 3/8 into a binary fraction. Time's up. Did you get it right?